Hi, and welcome to Autodesk Simulation TV. Today we're going to be doing a technical overview of Autodesk Simulation Mechanical. My name is Dave May, and I'm a technical specialist here with Autodesk. When it comes to digital prototyping, Autodesk has a very wide portfolio to help you, through all aspects of your design cycle. Now, what we're going to be focusing on today specifically is the simulation portion. Now, in the simulation division at Autodesk, we have a number of different products to kind of help you with different types of tasks that you may be needing to accomplish. First is going to be structural or mechanical type simulation, the plastic simulation product, which we have mold flow, and fluids, which is our Autodesk Simulation CFD package. Today, again, we're going to be focusing on the structural portion, or Autodesk Simulation Mechanical. Now, when it comes to different types of analyses or problems that you can solve in simulation, the first and foremost comes static stress or linear static stress analysis. This is just a basic structural analysis. So this is going to be a situation where you hold something over here and you push it, pull it, or pressurize it over here. Outputs from this are going to be things like displacements or deformations, stresses, strains, reaction forces. Pretty simple structural type outputs. Fatigue analysis basically takes your static stress to the next level. It's going to take a look at this simple static snapshot and figure out how many times or how many cycles the product can support. So think about the chair you're sitting on right now or the desk in front of you. If you were to sit on that desk, it may sag down a little bit, right? It's going to bend. It's not meant for people to sit on. But that's okay. You stand back up, it would come back up. Now don't be trying this at home. But if you sit down on it again and again and again and again and again, eventually, over time, it may fail, right? It could just collapse. That would be a fatigue failure. Now there's two types of fatigue, both high and low cycle are supported by the software. Linear dynamic analysis, or just think of this as vibration analysis, lets you look at a wide range of different problems that can result from, vibrations. So first off is natural frequency or modal analysis. This is just going to basically tell you the mode shapes of your part or assembly, which basically is just going to give you a feel for how the thing is prone to vibration. But everything beyond that lets you know how that vibration is going to affect it in the real world. Things like response spectrum is going to give you an idea of how it's going to survive a shock analysis, or things like a seismic test. Random vibration can be used to simulate things like shipping loads. And frequency response is good for anything that's attached to a motor or has a motor attached to it. All of these things are essentially ways to mimic the types of tests you would perform on a shaker table in reality. Now, everyone knows shaker table testing is very expensive, very time consuming. So anytime you can cut down the number of tests you need to perform, it's going to save you a lot of money. Now, heat transfer analysis, in my opinion, is pretty straightforward again. This is, conduction, convection, radiation. You're going to put input loads such as temperatures, a particular convection, a heat flux, things like that. And the outputs are going to be temperatures. You can look at temperature profiles, temperatures through parts. You can look at the rate of heat transfer through any given interface, things like that, right? And this is both steady state and transient. So you can look at time dependent or time varying loads, or time varying temperatures as well. Now, mechanical event simulation, or MES as we call this for short, for those of you who understand analysis a little bit, this is a full nonlinear dynamics package. Now, for those of you who have no idea what I just said, don't worry. Basically what that means is this is going to allow you to do motion. Not just motion, but full nonlinearities. So effectively, that means you can look at parts moving at different speeds, and it's going to consider all that. You can also look at different material properties, right? So you can look at things like steel and aluminum, basic types of materials, or you can look at things like plastics or hyperelastic materials like rubber or neoprene or foam. Not only can you do that, but these parts can also move. So moving at one speed versus another is going to cause different results because motion, velocity, momentum, acceleration are all integrated into the solution. That enables you to do things like contact analysis. Multiphysics is kind of a big word, but in reality, it's explaining pretty simple things. This is the idea that you can take different types of physics and have them work together. So things like a thermal stress analysis, that's a very common one. Essentially, you can take results from any heat transfer analysis, steady or transient, and read that into a structural analysis to take a look at things like thermal expansions, thermal stresses, etc. Of course, Autodesk Simulation Mechanical has interoperability with a variety of other Autodesk products. AutoCAD, Inventor, and Inventor Fusion are going to be primary modelers. We integrate very tightly with all of them, so you can bring in 2D or 3D wireframe, wireframe or solid geometry from AutoCAD. You can read files directly in from Inventor. There's plugins right within each software package to send it over. Same with Inventor Fusion. Mold flow integration is going to allow you to bring things like as molded stresses, fiber orientation, etc. in from any plastic flow analysis. Showcase integration lets you visualize your results in a high quality renderer. And you can use Vault, of course, to manage all this data. Now, Fusion's one that I like to talk a little bit extra about. Fusion is a product that comes for free, included, with your simulation package, with any seat of simulation. And it's basically, I look at it like a generic CAD seat, right? It's a universal CAD seat, meaning you can take files from any CAD source and manipulate them, modify them, delete features, etc., as if they were native. So it's really cool. It doesn't need feature trees. It's a direct modeler. Again, comes free. Great for simulation. Really helps with model cleanup. Now, showcase interoperability. I just want to show you a little image here to show you an example of what this can do. So this is going to take your results from any type of structural analysis, flow analysis, heat transfer analysis, etc., and render them in high quality scenarios. It just gives you more striking visuals. Really helps for marketing pieces. Whether or not engineers want to work with marketing, these things do tend to happen, right? So you got to be prepared, and this is going to help you make more compelling visuals. Okay. So you see here we're going to start off in Autodesk Inventor, and right at the top we have a simulation toolbar. We're going to go ahead and send it over to Simulation Mechanical. Now notice our geometry imports exactly from Inventor. And not only that, but also our material data. So if you're setting your materials up in CAD, all that data is going to come in. We're going to go ahead and just put automatic mesh on this, not do anything fancy, let the software do a lot of the work. If we can choose these internal surfaces, we can go ahead and add an internal pressure. So in this case, this is a valve body. A lot of times they're submitted to hydro tests or burst tests, and that's what we have here. So we can take a look at how it deflects. Of course, we can exaggerate that, which is a favorite thing of mine to do, so we can see how things are flexing. Or we can use set values. We'll do 1500. I like to use an exact number, which is easy to type in. That way, you can reference it in reports. So we can take a look at the full body, even though this is only a half symmetry analysis. Or we can go ahead and turn that mirror back off, look at our internal stress values, things like that. Now we can send this out to Showcase, but before we do, why don't we take a look at some of the results we can export directly from simulation. We have displacement videos. We can do stress video, just export AVI in 2 clicks, very easy. Or we can send it, again, to Showcase. Now when you send it to Showcase, notice what you get here. So we're just going to do a simple orbit, but just to give you a feel for it, this video was put together and exported in probably about 5 minutes total. And it's just a nice, high quality visual that really pops when it comes to your customers. Okay, so to recap, the Simulation Mechanical package is going to give you a ton of capability. First off, the static stress, the basic structural analysis. Also, fatigue analysis. So any type of structural results can be read in to determine how many cycles they'll survive. Linear dynamics and critical buckling, all part of that vibration package. Steady and transient heat transfer, as well as all the nonlinear. So you can do the motion, the stress, the dynamic values, as well as nonlinear materials, things like steel and aluminum yielding, or hyperelastic materials, and contact, so you can do the impacts, permanent deformation, etc. I'd like to thank everyone for watching this SimTV presentation, and if you have any questions, feel free to contact us via the Sim Squad.